Welcome. In this video, we will show you how easy it is to program in Pentaho MapReduce. You will see how a rich GUI development environment can simplify your MapReduce programming and turbocharge your development productivity. Our example will count how many entry page views occurred on a website by section. For the purposes of this demo, we're going to use a small data set, only about 450,000 records of parsed weblog data. Let's quickly take a look at the source data we'll use for our MapReduce program. I'm going to use Pentaho Data Integration's GUI development tool, Spoon, to do this. So we'll create a new transformation to start with, and we will go grab the Hadoop file input step. We will configure this step by browsing, connecting to our HDFS cluster, and I happen to know the file is in the weblogs parse short folder. It's the weblogs text file. We'll add that to our list of files that we want to select. Go to the Content tab, and there's no header in this file, and the file is of type Unix. And with that, we can pretty much just view the file content and see what it contains. So we'll go ahead and view the first 100 records, and we'll see that each record contains a IP address, a timestamp, the page or URI that was requested, the refer if it exists. If it doesn't, it's a dash, and then the user agent string. They are pipe delimited fields in this parsed weblog set. So for our MapReduce program, we're going to want to filter to get the records where the refer is unknown or null. It'll be signified by a dash. Those will be our entry page views. And then we'll want to grab the section out of the URI, and that section is denoted in the first string within the URI. So in this case it's download, then news, and then product, and so forth. So you can see that the URI is almost delimited by the /. We'll close this, and next we will create our mapper transformation. To create our mapper, we'll need to create a new transformation. And we'll need to add a MapReduce input step. Open that up. The key will be a string and the value will be a string. Actually, the key will be a byte offset, less important. The value will be the complete record that's delimited by pipe, so we'll have to split that up, which means we should use a field splitter. And we happen to have a step that does that, split fields. Connect those up, grab the value field, the delimiter is a pipe, and we know there's 5 fields. There's the client IP, there is the timestamp, type properly here, there is the URI, there is the refer, and then the user agent. We need to make sure we give these all a type. We'll make them all type string. And that does our field split for us. Next, we need to filter out those records that are not an entry page view. So we will use our filter step to do that. And filter rows, and we can pick. We know that it's an entry page view with the refer is equal to a dash. So this will allow those records to pass through that step. All of the records will be sent into the bit bucket. Next, we need to split the URI. We need to get the section out. So we can go back and use our handy split fields to do that. Remember the trick we talked about, potentially using the slash in the URI as the delimiter. And so our field to split will be the URI field. The delimiter will be the /. Now, since the first value is a /, it'll assume that there's a value before that, so that value will be a bogus null value. We'll just put in bogus. The next value will be the section we care about, and then if there's anything beyond that, it's the chaff. We don't really care about that. We're going to throw it away. These will all be strings. So again, we're just primarily trying to get that section that's after the first /. And we'll call this split URI just to keep it straight. All right, now with the section, we want to go look up something called a category. Our marketers have organized our sections, grouped them into categories, and they want the category included in this new data set. We've put the category section mapping in a file in HDFS, so we can go ahead and use our HDFS, our Hadoop file input step, to grab that data. Again, we'll browse and we'll connect to HDFS. That data happens to reside in our sections folder under the sections text. Go ahead and add that. This file again is of Unix type. It's delimited by, actually it's delimited by a tab. So you insert the tab there, it's there. There is no header to the file. We now need to go and grab our fields. We can say get fields, or happens to interrogate and see there's two. Fine, looks at the data types, great, they're both strings. The first field is the section, and the second field, actually the first field is the section, the second field is the category. Let's validate that. We can do a preview rows. Again, we're hitting HDFS, pulling the data back, and indeed, yes, the first column looks like section columns, the second one looks like category columns. So with this file input step, we now can basically cache that lookup table, there's only about 35 records or so, into memory. So this will be cached in each of the map tasks. We now need to do a lookup using that step, and we're going to use a stream lookup. So we'll flow the records from our main transformation process into the stream lookup, and we'll flow the lookup table from our Hadoop file input. And actually, let's rename that and call that our section category data. Okay. All right, so let's go into a stream lookup step. The lookup step we're pulling data from is the section category data. The field that we're going to match from the mainstream is section. The field we're going to match from the category section data is also section. We can do get lookup fields. We care to keep the category. So we're matching on the section from our mainstream with the section from the lookup table, and then we're going to return the category. And I can right click on this step and show output fields, and you'll see that indeed the category has been added to the stream of fields in this process. Next, we need to make our new key and value. We have to emit a key and value from the mapper. To do that, we're going to use a scripting step that basically allows us to, actually it's a Java expression step, sorry. It allows us to do this, so it's a user-defined Java expression. That's going to be the easiest thing to do. And we'll create a field called new key. And the key is going to be the category and the section. So we'll say category, and this is just a little Java expression, plus, and we'll pipe delimit this this value, and we'll add the section at that. Right? And then the new value, it's just going to be an integer. It's going to be a value of 1. And I actually forgot to put the string in there for the first value type. So what we're doing here now is the key that we're going to emit is going to be the category and section. The value is going to be 1. So each record that comes out is 1 entry. The reducer then will sum all the values and come up with a total of entries for a category and section. Remember that with the shuffle and sort process of Hadoop, the value, these records will be flowing through in key order to our reducers. All right, and then finally we need to close this out by adding a MapReduce output step. And here we go. And we have to tell it what the key and value fields are. The key field is going to be the new key, and the value is going to be the new value. We save this, and we'll call this our mapper. And we're done creating our mapper. Okay, let's create our reducer. So we'll create a new transformation. We will go ahead and grab the MapReduce input step. Now remember, the key that was emitted from our mapper was a string. It was the category concatenated with the section. The value is an integer. It's the number 1 coming out for each record. We want to sum the values for that key. We know that the records are going to be coming to us in key order, so we don't have to do any sorting in our reducer. We can just group them. So we have a group by step that allows us to do that, effectively summing the values for each key. Do that, and the grouping field will be the key, and the field that we're going to sum is the value, and we'll sum it, and we'll give this thing a name called sum value just to differentiate. Okay, I understand. All right, so what's going to come out of this step is going to be the key and the sum value. So maybe 20 records flow in for the same key, but 1 record will flow out, summing the values into the new sum value field. Okay. Now we need to create our key and value that are going to be emitted from the reducer. So we'll use our handy Java expression step again. Get that squared away there. Here we go. And we are going to create a field, we'll call it new key. And the new key is going to be basically a field that we're going to throw away. We're going to basically block that key, suppress that key from being emitted. We just want to emit a new value, being the entire record. So it really doesn't matter what we put in here. We'll just put the number 1 and make it an integer. But the new value is going to be more interesting to us. We're going to take the existing key, that was the, remember now, that was the category concatenated with pipes, concatenated with a pipe, concatenated then with the section. And we will concatenate to that the new value, right? And which was in the field called sum underscore value. This will be a string. Right? So the record that will be coming out will have the category, pipe, section, pipe, and then the number of entries. And again, we have to close our transformation here with the MapReduce output and tell it what the key and value fields are. So the new key is coming out and the new value is coming out. Right? Let's save this. We'll call that reducer. And our reducer's done. Well, now that we've built our map and a reducer, we are ready to build our Pentaho MapReduce job. So let's create a new job. Every job in PDI must start with a start step. And this job's going to be real simple. It's going to have one step, Pentaho MapReduce after the start. Let's go ahead and configure that. We can browse for our mapper, which is here. And then our the input step to the mapper is MapReduce input. And we'll go ahead and copy that because our output step is the MapReduce output. We don't have a reducer or combiner, but we do have a reducer. Again, we'll browse for the reducer. There we go. Okay. And again, we'll have the same names for our input and output steps. Now we need to set up our job, define to Hadoop how it's going to process. We're going to suppress the reduce key. We only care about the reduce value being emitted or placed in the output files. The input path is weblogs/parse underscore short. This is where our source data resides in HDFS. Our output path will create another folder called weblogs entries. So these are going to be the entries to our website. The input format is the Java class of the input format for our mapper. So MapRed text input format, and the output format's the same, only its output formats will cut and paste. All right. We do want to clean the path before execution. What this will do is remove the weblog entries folder from HDFS in case we run this MapReduce job over and over again. And now we need to define how we want to run in the cluster. Well, we are using a Cloudera distribution. I'm using a pseudo-configured, pseudo-distributed node in my virtual machine here. Working directory, we'll just give it /temp. And then the host is localhost. The port is 8020. Again, localhost for the job tracker. Its port is 8021. We're going to keep the map and reducer tasks as one. We're just running on a simple VM here. We certainly could mess around with that, but for now we'll keep it simple. We'll enable blocking. This will allow us to see logging messages back in Spoon and show us the progress of our MapReduce job. The logging interval, we'll have it respond every 5 seconds and see how this job is progressing. Now before we save this, we have to give the job a name it'll be submitted to the job tracker with. So we'll just call it demo. Say OK. All right, let's save our PDI job here. We'll call it mr_job. Oops. And now we're ready to run. So we can click the run arrow, launch it, and let's watch the log messages flow through here. It'll take about 25 seconds or so in my environment to process this data. We are set up now, 100% complete. Now the mappers should start executing. It might take a few moments for them to start. Here they are. They started and they finished. And then the reducer is next. Let's see what we got here. I'm still getting ready to reduce, so the shuffle and sort must be going on, moving data to the reducers. Get a little progress. And it's complete. So our MapReduce job now has run on my cluster. Let's go and look at the output data. We could certainly go and use command line interfaces to interrogate HDFS, but since we're in Spoon, let's use Spoon. We'll go ahead and do a Hadoop file input step. And let's grab that. And again, we'll connect to our HDFS cluster. The output was placed into the entries folder, right? And say OK. Go ahead and add that. Now the files are always called part under, dot something or other. So we'll just say part.star, and we can show file names, and it'll tell us yes, there indeed was one file because we had one reducer. And we can do we need to go to the content and make sure we tell it it's Unix and that there's no header. And then we can go ahead and show file content. And this is what we have. We have the, it looks like the category, the section, and then the count of the entry page views. So we produced exactly what we said we were going to produce. And that completes our demo. So we've just demonstrated how easy it is to develop and execute MapReduce programs using the Pentaho visual programming environment. There was no Java programming, no Java compilation, there was minimal scripting, but we were using a technology that's very accessible to your experienced ETL developers. Hope you found this helpful. Thank you for watching, and thank you for your interest in Pentaho.